So here we go. Okay, so as I was saying, right, you want to be able to prove what you need right away. But if you're not able to prove what you need right away, you do not force it. We then have to do something called a detour, meaning we'll have to prove another pair of triangles congruent, see some things to help us to get originally what we needed to get congruent. So let's look at this first problem. We have segment AB. We have segment AB congruent to segment AD. Then we have segment BC congruent to segment CD. Right, and we need to prove triangle ABE congruent to triangle ADE. All right, so again, what I said, your instinct should not be to take a detour. Your instinct should be, let me prove these triangles congruent and see what we have, but let's not force it. Do you agree triangle BAD, AB and AD are legs congruent? If the legs are congruent, what else can we say are congruent? The base angles. Now, I cannot call the base angles B and D. Why can't I call the base angles B and D? Michael? Good, because multiple angles could use the name B and D. So I'm going to give them numbers. Do you agree? Don't do this because it's not going to work. But do you agree we can say angle 1 and angle 2 are congruent? If legs are congruent, then base angles are congruent? Yes. All right, can I also do reflexive here for AE? Don't force it. This is not side angle side. This is not side angle side. What is this?
Side angle.
Side angle or angle side. Can we use angle side or side angle? Is that a method of proving triangles congruent? No, you cannot.
There are no right angles.
Yep, this is not hypotenuse leg because there are 1 and 2 are not right angles. Okay, so this is not going to work for us. These two triangles right now are not going to work for us. So now we need to take a detour. We need to find a different pair of angles, a different pair of triangles that we can prove congruent. All right. Well, at times people have said the bottom triangles, BCE and DCE. Does everybody see those bottom triangles? Still not going to work. I'll show you why. Don't write this, but I'm going to show you why they do not work. So they'll see that we already have a side. Then they're looking at triangle BCD once again. And you have the legs congruent. If the legs are congruent, then the base angles are congruent. So you could say like, oh, angle 3 and angle 4 here are congruent. And then you could do reflexive. Once again, what is it? Angle, side, or side, angle. Is that a way of proving triangles congruent? Absolutely not. So these bottom triangles also do not work. Does anybody see another pair of triangles? Vin?
Would it be ABC and AEC?
You got it. I'm looking right now at the big triangles. ABC, right here that I'm outlining in blue. And I'll outline it in green, ADC. Do we agree we already have two sides of the blue and the green triangle? What's going to be my third side? Julia? AC. You got it. So step 1 is our given. Step 2 is going to be AC congruent to AC reflexive. And then I can go on and say triangle ABC is congruent to triangle ADC, side. Okay, so now we know that's not the triangles we were told to prove. We're helping by proving, taking this detour and proving these two really big triangles congruent. There's something in the really big triangles that I can CPCTC that will help me get the little triangles congruent. Now the little triangles we need are these two triangles that I'm highlighting in yellow. Simon, give me 1 second. So just so you know, you are only allowed to CPCTC full sides or full angles. You are not allowed to CPCTC anything swimming in the middle. So for example, BE and ED, are they a side of those big triangles that we got congruent? They're not a side, so we cannot CPCTC them. They're sort of floating around the middle. They're not anything we can CPCTC. You can only CPCTC full sides or full angles of the triangles you proved congruent. Okay. So there's no side I can CPCTC. They're already all congruent. But does anybody see a pair of angles that are the same exact angles in the big triangle and in the small yellow triangles? Daniela.
Both sides of A.
You got it. Can I call them 1 and 2? Does everybody see angle 1 and angle 2 in these triangles? Isn't angle 1 a full angle in the blue triangle?
Yeah.
Isn't angle 2 a full angle in the green triangle? And they're also full angles in the yellow triangles. So that's what we're going to CPCTC. So step number 4, I'm going to say angle 1 is congruent to angle 2, CPCTC. All right, so now I have a side and an angle. Now we have a choice. You could either do AE reflexive, and AE reflexive is different. We did AC reflexive. Are segment AC and segment AE the same? No, so we would have to still do AE reflexive. That would work. Or you could do legs to base angles, right? So you can either do side or angle side angle. Does it matter which one you choose? No, they're both correct. They are both correct. So I'm going to do AE reflexive. Yeah, they're two different segments, right? AC is one segment, AE is a different segment. And then we're going to have triangle BAE congruent to triangle DAE. Side, angle, side. And that's what it asked us to do, so then we are done with that proof. Can we move on to number 2? All right, let's see what we have here. We have that segment BC is congruent to segment DC. Oh, I marked BG, sorry. BC congruent to segment DC. There we go. Then we have segment CG congruent to segment CF. And we have angle AGB, I'm going to call that angle 1, congruent to angle EFD, which I'm going to call angle 2. Right, our goal is to get segment AG this one right here, congruent to FE, this segment right here. Okay, so should your instincts be to take a detour? No. So if we need AG congruent to FE, we need to first prove a pair of triangles congruent, and then we could do CPCTC. I think most of us would think about, don't do this because it's not right, think about these two triangles. Do you agree? All right, so CG and CF, doesn't that count as full sides? All right, can I also do vertical angles? I could do vertical angles here. But now the question is, does CB and CD, do they count as full sides? CB and CD, they're too short. Can I just use addition and get AC and CE congruent? No, why can't I use addition? Yep.
Aren't there more angles that are affected by it?
I'm sorry?
Aren't there more angles that are in it that are affected by it? So
More segments?
yeah.
More segments, exactly. Right now, I would need A, B, and D, E to be congruent to use addition also, wouldn't I? I can't just have part of the segments congruent. I would need both parts of the segments congruent, and then I could add to say the full segments were congruent. So addition wouldn't work here. Are these triangles going to work? No. Are these little triangles AGB and EFD going to work? No. So we need to take a detour. We need to take a detour. Which triangles can I prove congruent? Which triangles can I prove congruent? Maya.
BGC and DFC.
You got it. BGC, this one, and FDC, this one. So we can get these two triangles congruent. We already have two sides. What else can I say, or do I have to write down? What else do I have to write down to get these triangles congruent? Simon.
GCB congruent, FCD, vertical angles are congruent.
You got it. So we got angles 3 and 4 right here. Angle 3 is congruent to angle 4, and our reason is going to be vertical angles are congruent. Okay, so now I can get triangle BGC congruent to triangle DFC, side, angle, side. And now we have an option, right? We knew we were taking a detour. We knew this was just a means to an end, right? Getting these triangles congruent to help us get another pair of triangles congruent. Remember, our goal is to get AG, this blue segment, congruent to FE, this segment. So we have a choice. We can either try to prove the big triangles congruent, try to prove the big triangles congruent, or these little white ones. Both will work. Both will work. It all depends on how you want me to do it. How many people are thinking the little white ones? All right, that looks like majority. So let's go that route. So if we're going to prove the little white ones, can I first CPCTC BG and FD? Say BG congruent to FD CPCTC. I'm not going to draw my line because I need to CPCTC more. All right, so now the next thing we're going to see PCTC is inside the yellow triangle by B, I'm going to call this angle 5, and inside the yellow triangle by D, I'm going to call this angle 6. And I'm going to say angle 5 is congruent to angle 6 because of CPCTC also. Anybody know where I'm going with this? Livy? You got it. So next to angle 5, I'm going to call this angle 7. And next to angle 6, I'm going to call this angle 8. Well, 7 and 8, aren't they angles inside the white triangles? And 5 is a supplement to 6, as 5 is a supplement to 7, and 6 is a supplement to 8. So that's my next step. I'm going to say angle 7 is sup to angle 5. Angle 8 is a supplement to angle 6. Def of sup. Can I now say 7 and 8 are congruent? Yeah. And that's sups of congruent angles are congruent. You got it. So now the white triangles are congruent. Triangle AGB is congruent to triangle EFD by angle side angle. Can we now see PCTC, AG, and FE? Absolutely.
So on most of these, you're only gonna have to find the congruency of like two different triangles.
Mm-hmm.
So like we proved the first one to prove the second.
Exactly. All right, let's do another one. So here we have segment AD is congruent to segment BC. And we have segment AF is congruent to segment EC. Oh, because it was big and I had space.
That's why I was thinking.
No real reason. Right. Then it tells us that BD is perpendicular to AF. If BD is perpendicular to AF, what can we conclude there? What can we conclude if BD is perpendicular to AF? Vin?
Right angles.
Right angles. Where? By which letter?
F.
F. So I'm going to call them, well, step number 1 we know is our given. So by F, I'm going to call these angles 1 and 2. But then it also says BD is perpendicular to EC. So where else am I going to have right angles? So I know 1 and 2 will be right angles. What else will be right angles if BD is perpendicular also to EC? Simon.
Angle E.
Good. We're going to have more right angles by angle E. So I'm going to declare all 4 of these right angles. Do I know which ones I'm going to use? No. So that's why I'm just declaring all of them. So I'm going to say angle 1, angle 2, angle 3, and angle 4 are right angles. Who knows the reason for this? Sion.
right angle square. Oh wait, sorry. Perpendicular. Depth of perpendicular.
You got it. Depth of perpendicular. All right, and then what should I say about all of these right angles? That they are congruent. So we're going to say angle 1 is congruent to angle 2, congruent to angle 3, congruent to angle 4, and that's what Sion had said, right angles are congruent. Okay, so let's look at what we want to prove. We need to prove AB congruent to DC. All right, so I see triangle AFB and triangle DCE right off the bat. I have a side and an angle, a side and an angle. That's pretty nice, but there is no other side or any other angle that we can get. So these two triangles on the side are not going to work. Right? Then I see the big triangle ABD, and CDB. You guys see those big triangles? In those big triangles, we have a side. We can do reflexive side, but then that's it. So those big triangles are not going to work. So our direct triangles are not going to work, so we need to take a detour. Does anybody see a pair of triangles that will work? Does anybody see a pair of triangles that we can say are congruent? Max?
I think BEC.
You got it.
and DF.
You got it. So this triangle we can say is congruent to this triangle. And based on everything we've marked and written, these triangles are already congruent by what method? Only 2 people, really? Look at your markings. Danya? It is HL, right? It looks like angle side side, but because of the right angle, it's not angle side side, it's HL, hypotenuse leg. So I can go ahead and say these two triangles are congruent. Triangle BEC is congruent to triangle DFA. And that is HL. Okay, so that was our detour. Now we have to CPCTC some things that are in the purple and blue triangles to help us get another pair of triangles congruent. Now our choice is, do we want to go for the white triangles or the big triangles? I will tell you they both work. Do we want to go for the white triangles or the big triangles? How many people want to go for the big triangles? How many people want to go for the white triangles? Okay, the big triangles are easier, but we will do the white triangles. So, for the white triangles, the only thing that I can potentially CPCTC from the blue and purple triangle, do you guys agree that segment BE and segment FD will be congruent? That we can CPCTC them B to E and D to F? We see that? Okay, so let's go ahead and CPCTC those. We're going to do something with it, yep. So now we're going to say, which segments did I call them? B, E, and D, F. All right, so that gives us, so we use B, E, and D, F. Let's mark it. So that's B to E, this one right here, and F to D, this one right here. They're too big, right? We want BF and DE. That would be ideal. So B to E and D to F are extending outside of our white triangles. We would like BF and DE. Does anybody see how we can get those? Jerry? And then subtract it. Do we see the overlap on FE? Because it's overlapped, we can say we're going to use it twice and then subtract it from each of them. So we're going to say EF congruent to EF. Reflexive. And then we can do subtraction. So then we'll have BF and DE. Subtraction. So now these triangles, look at the white triangles. Aren't they congruent by side, angle, side? So now we can say the white triangles are congruent. BAF, triangle BAF, congruent to triangle DCE, side, angle, side. And then lastly, we can go on and CPCTC what we need, which is AB and DC. So AB congruent to DC CPCTC. Alrighty, so now what I want you to do is try one of these on your own. And I will be coming around to help you, and then we can go over it. All right, anybody want some help? Anybody stuck? Yeah, so now we gotta figure out which triangles you actually want to get.
Remember I called it inserted?
Yeah.
So I can put it in the
You only use those keys.
That's something different. So you have double Y reflexive. You can do AY reflexive. So that will get you another side.
I don't either. Then she explains that maybe we'll do it in class. We'll draw. What is it?
So do these are part of
Yeah.
I can see how
Well, no, they're already congruent, right? X, Y, and Y that was given. So now you're trying to get
Alright, I guess I'm with you.
these two triangles congruent,
I
right?
can use that side.
I'm not Photoshop.
Well, you don't have a third side. So that would be X, A, and Z. Can I see this?
Am I my own key pretty much?
No, it has to be like an actual side or corners.
I just joined it.
Actually, no, you see, these are two different triangles.
2 minutes I sped around.
Yeah.
So,
You didn't even ask me. I just told him what I could do. He's like, okay, you're in the club now.
Different colors. Sometimes different colors really help.
I need to find my stylus. I think some sort.
Oh, is that why you've been writing
Did someone
it down?
steal your
Yeah.
stylus?
I had it in this class and then
And then it's gone. It's gone. Go to IT, they'll give you a new one.
Yeah, supposedly IT's been giving them out for free.
oh really?
Yeah, you can go to IT.
Where is IT?
IT's in the library.
Library?
Yeah.
It's right in the learning commons.
Oh, I'm about to call it the
You call it the library.
I messed up on this piece.
I call it the
I
library.
call it the library.
It's called the learning.
I call it the
library.
library. I call it the library.
They get very upset when we call it the library, but I call it the library.
It has books. It's fine.
So try to use any
Why
of
are
the
they-
stylus words around in this class.
Alright, I need to show me the on shape so the side can do it.
Triangle.
Please
I
show me
made
the minute.
this in odd shape.
Dude, this kid's building a drone. He's building like a DJI Matrix.
No, it's not a matrix. It's a custom made.
We already have all the
It's a
sides.
custom made drone.
You can't see
Remember
pieces.
the thing
Are you this one?
Son, you could do this one, son. This one is, I need, all it is just you make a circle and it's on.
Basically, it's X by Y.
Yes.
Yeah, we call them
Robotics.
that.
Robotics.
Wait for what?
Robotics. The class.
Oh,
Robotics class.
oh.
Aren't they
You're
full
actually
angles?
building
So
a-
it's right here and here.
So
Are
this
they
is
full
one
angles
thing.
in the triangle?
Yeah.
And aren't they full angles in the right triangles?
The class.
So that's what we're
The
gonna
class. Yeah, the class.
But you need to have like experience.
Yeah.
Yeah, that's experience.
I remember 6 minutes.
Yeah, but what about design?
CSCs and like.
What about
Son, you barely know
And then
these
the
on
right
shape.
triangle
What about-
will be
Yeah.
divided
what
by
about
On shape is different.
what about programming? What about programming?
Programming? No, not.
Okay, these are the angles. These are robots. You can talk to us like a program.
You got it.
I can wire that.
All right, guys, let me go over this proof with you.
Probably better for you to sign that. Alright, fine. I'm sorry.
All right, so here we have WX is congruent to WZ. Zoom this in a little bit. And XY is congruent to ZY. Our goal is to get these two triangles congruent. These two yellow triangles. Different colors really help in detours. So we want to get these two yellow triangles congruent. So right off the bat, I said, okay, well, we can do legs to base angles and then reflexive. But that doesn't work because what is that? ASS, right? So this does not work. This does not work. So we need to take a detour. What is our detour? To go WZY and WXY, to go bigger. So we're going for this triangle and this triangle to be congruent, the purple and the blue. Well, do we agree we already have two pairs of sides congruent? And then can I do reflexive? So I'm going to say WY congruent to WY reflexive. Then I can go on and say triangle WXY is congruent to triangle WZY side, side, side. All right, now, what can I CPCTC in the purple and blue triangle? That's also a full part of the yellow triangles. Can't CPCTC anything swimming in the middle. Michael. You got it. The two angles by Y, I can call them angle 3 and 4, or 1 and 2 if you wanted, and CPCTC them. And then we can say triangle XAY. Oops, sorry. No, I cannot. Not there just yet. We just have a side and an angle. What am I missing? Maya.
You could say that the base angles are congruent, so
Yeah, we can say the base angles are congruent. Give me 1 second. Let's see who's calling me.
Angle side angle. Because it's expressed as this one. So it's a low.
Roll.
That's for the robotics.
It's crazy.
All right. So here we have, we can either do legs to base angles, right? So I can call these 1 and 2. Or what else could we have done?
wait, so does like reflexive not work?
It does work. Or we could have done reflexive, right? So we could have done legs to base angles, and that would have gotten angles 1 and angle 2, which would have made it angle side angle. Or we could have done AY reflexive, and what would have that have been? Side angle side. Does it matter which option you choose? It does not matter. How many people did reflexive AY? How many people did legs to base angles? Okay, so I'll write it up reflexive since that's the way the majority did it. So we're going to say AY is congruent to AY reflexive. And then we could say triangle XAY is congruent to triangle ZAY side angle side. All right, so we are done with this lesson.